Okay, so in this second video we will try to analyze the image, and we will want to count the small cells and the big cells here and classify them depending on whether they have high or low intensity in the green channel and in the yellow channel. So in order to do that, we have prepared the image. So let me just quickly show you how it looked like before the processing and the segmentation of the region. So roughly speaking, this was the original data set, and we have restricted the signal to a smaller region here. So this will speed up the calculation and will also allow us to avoid some too much complicated decisions to make to decide where and what kind of spots will belong here to our analysis. So in order to work, what we need here is a new spot detection tool. So we click here, new spots here, and in this case we want different spot sizes. We want to classify the spots and maybe also calculate the shortest distance. It might come in handy, we never know. So next step is to select what channel we will work with. So we have here several channels, so we have made them in the previous video, and we will use, let me just check which one has the clearest signal here. I think we will use, yes, the green channel, which was processed here, as our original data set, so channel 9 here in this case. So again, we have to estimate the diameter of the spots we want to study. So it doesn't need to be very precise. If you want to get more precise measurement, here we can see it's roughly 12 microns for the large ones, and yes, around 10 for the smaller ones, maybe even smaller, 6 microns. So let's go back to the 3D view, and yeah, let's put this to 12. We don't want to do any PSF irrigation along the Z-axis here. It's not needed since it's quite flat. And yes, we can leave the background subtraction, even though we already had previous steps involving background subtraction. Next step here. So here we will have to make sure we get all the points we want. At this step we can filter them, but what we really want is to make sure all of the necessary spots are there. So I want spots, for instance, on those small structures here, and make sure we have them. So let me just enable again spots. So here it's the case, and if we play here with the quality threshold, you can see we will quickly lose some of them. So I re-enable them progressively until almost all of them are covered. So here I'm sure I'm not missing any of them. And then we can additionally filter out those who do not belong to the structures we want to study. So, for instance, spots into these areas here, we might want to get rid of them right now. So in order to do that, we can add a new filter here. And now it's up to us to decide what kind of measurement we will use to filter out those spots. So this can take quite a lot of time to fiddle with if you don't know really your sample. Here in this case, if we just see how the signal looks like and those structures, it's probably a bit more weak in the yellow channel, and in the blue channel it's more intense. See, so we can probably filter out based on those two criteria the spots we do not want here in the green channel. So let's try this. We can change, look for intensity mean, and then we have to look for the right channel here. So we have several, and so the right one would be, this is channel 9, 8, and this is channel 7. So let's see how it works with channel 7. And so here we have the reverse of what we want. So let me enable everything with the left mouse click, and with the right mouse click here I disable the high part here. So as you can see, we are progressively removing spots that are not needed here in this case. Let's see roughly what it looks like. So the on-off toggle allows me to see the effect of the filter here. So I think it worked quite nicely here in this case, so I will stick with this for the moment. Obviously some of the spots we have detected were missed here, but I mean, statistically speaking, it shouldn't be an issue. The problem I see here is that those big green cells are now missing here. Yeah, so we really want to make sure we include those back in something like this. Yeah, and now we still have those there. So let's see if we combine this with the new filter, this time based on the other channel, if it will work better. So in this case, in the channel 8, and interesting. Yep. So I think with the combination of those two filters, we can eliminate the spots which are really weak in yellow and which are really strong in blue. So we keep only the spots that we are interested in. So we don't want to be too restrictive here at this point, because we will classify the spots we have left afterwards, and we can also have a filter step kind of at this time. If we look here, now we are missing a lot of spots in this region. So I don't know if this is due to this filter. Or this one. probably the quality threshold here. Yeah, it was too set too high here. Okay. So this is starting to look really like I want it to be. Okay, something like this, maybe. Let me switch quickly on and off the spots. Okay. Obviously, we can also add a last filter, and this time using the intensity mean from the channel we are using here. So we can remove those who are really too weak here to this region. Generally, when you see the histogram here, if you can see two separated spikes, you can very easily discriminate between two different populations. It's not really the case, but I mean, we've managed to get the spots we want here, so I won't go further with the filters. So let's move on to the next step, which is to define the spot regions. So again, let me just switch off the spots for a moment, and you can probably see that if we want to base the spot region on the intensity, it's probably not ideal since it's not very homogeneous, so we probably want to stick with local contrast. And now the next step will be to define a threshold, and this time I would suggest we try both to see how it looks like. So what we want to do here is define the region occupied by the spots. And I will probably use region border. So visually we don't see any difference for the moment. We just want to make sure the very bright areas are covered here. So it should be fine. Okay. So now we have detected the spots and defined the spot sizes based on the different contrast. Let me just switch off the volume to see the spots. Yeah, maybe they were too restrictive. If I switch off here, we will see better. Yeah, it's a bit too small for my taste. So let's go back one step here. And do something like this. See if it looks better. Yeah. Still not the best approximation. Let's try something like this. Yeah, it's a bit better. Okay, so what we can see now here is that we have colored the spots in two categories here, or two classes. And the goal here is now to define a filter to discriminate between the large spots, or the spots belonging to those large cells, which are Purkinje cells, and the others. So we have several ways of doing this, and I think, based on the several tries I've made, and then that the best solution here is to use a machine learning based filter. So in order to do that, we have to select some of the spots and feed them as samples for each of the classes we want. So we can just click one spot and add it to this class, for instance. Click the next one, add it. So this can become quite tedious very fast, especially if you want to sample the small ones. So we can switch here to the circle selection mode to select multiple spots in one go and add them here. So we really want to make sure we get multiple samples from several different regions. So let's look for them here. Okay, and let's go back to the individual selection tool to add more large cells. So we can select multiple large cells by keeping the control key pressed here. I just want to add a couple more here, maybe 3 or 4, like this. And then we can train and predict to see what it looks like. So you can see the progress here. It takes time because it's doing many calculations. It will take into account all the measurements we had access to before using the filters, and try to build a machine learning model fitting the two classes we have defined here. So it's not only based on intensity, for instance, it's also based on the size, the standard deviation, and taking into account all the channels, not just one channel. Also the position of the spots relative to each other, and so on. So let's have a look. So we have purple cells really only at the periphery. So I think our model is working quite well. Maybe it missed 1 or 2, so we could add more spots and tell the system to use them and retrain it. So we can do that quite easily. Let's select this one and add it to the to this pool here. Let's check quickly. Is there another misstep? Maybe. Yeah, maybe this one here should go into this pool. Let's do another round of training and prediction. So this time, is it done? Yeah. Or is it still doing it? I think it's done. Yeah. So So you can see here it's actually worse than before. So let's try to retrain this. We can also, as you can see, manually correct. We do not need to retrain everything each time. Yeah, better right now. If there is just one mismatch, yeah, for instance, this one here, we can just simply add it to the correct class like this and move on. So here we have now separated the large cells from the small cells, and now we want to do another classification. So let's give some relevant name to the classes so we won't be confused. So those are Purkinje cells, and those are other cells. I don't want to get too much complicated here. So this is the first set, and let's add a new step here. And what we want to do is have as input, let's say, only the other cells. And from those other cells, what we want to see is which of them have also a high signal into the yellow channel. So here in this case, we can simply stick with a 1D filter and select the intensity mean. Or maybe intensity sum of squares is also quite nice. So it's channel 8 here, and we can separate them using this slider here. So since the high values are on this side, I will change the color. Let's call this yellow positive, and this one yellow negative. So let's just check now if we disable this channel and enable this one. Is this correct or not? Maybe by enabling and disabling the spots, maybe temporarily change this back to red so we see them a bit better. Or we can also change the display here, which is probably a bit too intense. Something like this. So, are the red spots on bright yellow cells? I think I'm still a bit too restrictive, and again we can see here definitely one population of cells and a second one, so we can probably decide this way how to separate the two populations. But obviously there are many ways of doing this kind of work. So let's switch this back to yellow if we are okay with this, and we can do again a new set, and based on the Purkinje cells, and do the same kind of exercise. So I will use the same statistics here. So sum of square with the channel number 8. We see the same kind of division between the population of cells. And so this will be yellow negative, and this one yellow positive. And we can also put them in, let's say, something more like this, orange, and the other, let's say, kind of yellowish green, something like this. So it's more, it's looking similar to the rest. And when we have finished, we can terminate this wizard. And now if we go on the statistics here, we can see the number of spots per class we have created. So if it's not very clear, here we can change the name of the sets to something else. So it's maybe more clear than the set 3 is about the Purkinje cells and the set 2 is about the other cells. But at least here you have all the numbers based on the different classes. And if you, for instance, want to display, so it's not yet, sorry, it's here in display, you can see here only the classes we are interested in. You can, for instance, check, okay, with the Purkinje cells, which are the ones we are interested in. So we will see in core the yellow are the positive ones, the green are the negative ones. And if we can check here, we will get rid of all the other cells. So it's a nice way to display this, and we can even go back to the original data set. That's maybe too much, to see our detection here on our original data set here. Okay, so this is it for this demonstration, and don't hesitate to ask me questions. Bye bye.